Okay, this is a flipped classroom module looking at mole conversions for all my students to kind of teach them how to do conversions from grams to moles and moles to grams, particles to moles, particles to grams, because we need this to understand and do chemistry in the classroom. So remember, when we do stuff in chemistry, everything's done with the moles. In a balanced chemical reaction, the coefficients are the number of moles of material, not the number of grams. However, we measure stuff out in grams. So we've got to find out a way or have a technique to go from grams, which is the macroscopic world, into moles, which is the microscopic world. And so these conversions will show you how to do that. So basically the skill set that you need to master this concept is, can you multiply and divide a series of fractions / ratios in math? And so here we go. Here's a ratio of 1 over 2 times a ratio of 3/2 times a ratio of 5/5. And therefore, if I multiply all these together and then I further reduce, I get 3/4. Or if I convert it to decimals, 0.75. How did I get that? I multiplied the top numbers, the numerators of each one of the fractions / ratios together, and I got a product here, 15. And I did the same with my denominators, and I got 20. 15 over 20 is the same thing as 3 over 4. And then I reduced it, if I wanted it in decimal form, to 0.75. That's all you're doing, right? So everything on the top gets multiplied together, everything on the bottom gets multiplied together, and at the end of the day, you divide everything, right? So if you were to set this up using the same technique down here, two boxes next to each other are multiplied, top and bottom, and then in between, if you were to do that, it's just divide. So how do we do this, right? If I was to take the top ones again, and I said 1 over 2, I put that in this box. Remember, this box here represents one of the ratios, or this fraction here. So everything in this box is just one fraction. And then I did down here 3 over 2, that's a 3. And then 5 over 5. And I did exactly the same stuff as I did up here. I'm going to multiply all this together and then get a number, which that number would be 15. And then the other number on the bottom would be 20. And this is basically that there. So we're going to set it up this way right here, as I've pictured right here for all the things, except instead of just doing fractions and ratios, we're going to actually have to have some units in here, and that's where the dimensional analysis and factor label method come into play. We'll show that on the next slide. So the goal of dimensional analysis is twofold. One is a very structured and rote process in order to do conversions. Now you may say, well, I already know how to do conversions. I can do them pretty much, pretty quickly using some quick calculations in the back of my head and all that stuff. And that's true. The problem that comes into play is when you use units that you're not really familiar with. And the other thing that comes into play is if you don't keep track of your units, you can get some of these fractions or these ratios to flip. And you don't want that to happen, right? So by doing the process as it's stated and keeping track of your units, you will always get the correct answer provided you push the buttons on your calculator right. And that's why we teach it. So the key to solving all these problems is to understand what you are given and what you are trying to find. Then you're going to have to put that information in the proper order and sequence in the setup. Once you do that, the math is pretty straightforward, right? So you need to understand what you're given. That's always going to be something with a value in a unit. what are you trying to find, and then when you do all that, make sure you put them in the correct boxes. The given information always goes into the top left box in your sequence, so the farthest one to the left on the top, and that goes over 1 in the bottom left-hand box. Whatever you're trying to find, the units go in the second box to the right on the top. What you're trying to convert from, the units go in the bottom box on the right. So there's 2 boxes, one's on top of the other. So in other words, the numerator box and the denominator box. The numerator box has the units that you want to find. The denominator box has the units that you want to get rid of. The numbers that go with those 2 units correspond to the conversion factor. For example, if you'd said feet and inches, 1 foot is 12 inches. So wherever the word feet is in that conversion, you would write the word 1, a number 1. Where the inches is, you would write 12. Once you do that, everything else sets up and falls out of place. You just cancel the appropriate units and then do the correct math. Let's see how it does on the next page. Okay, I'm going to show you how I solve these problems, and I have solved these problems all the same way. And again, this is the rote process. In other words, if you do the same problems over and over again and you solve them the same way, you should never get lost. So the first thing I'm going to do is always look for what am I given. So when I do that, I look at my problem and it says how many quarters are in $127. So the thing is I'm looking for is a number and a unit, and the only one that's a number and a unit in the problem is $127. So I basically take that and I put that number right here. That goes here, and then I add it over 1, right? That's the next step. Now before I move on and try to figure out what am I trying to find, I take whatever unit I was given, which is the dollars, and I'm going to put that right here. Right away. I'm not even going to, try to figure out where it goes. It goes on the bottom. So whatever you write here in this unit goes down here, whatever that unit is. You're trying to bury the unit, right? So in other words, you're trying to get rid of it. You're trying to convert from it, so you're going to get rid of it. So what do you do with stuff you want to get rid of? You throw it in the trash, and the trash gets buried, and so therefore it's always below ground. So I think this is like the ground. Now, I go back to my problem again, and I'm going to figure out what am I trying to find. And my trying to find is how many quarters. So this word is the word that goes on the top, because that's what we're trying to convert to. So this is quarters. And how do I know that? Because I want to go from dollars to quarters. I'm going to jump from dollars to quarters. Now, I don't have any numbers over here yet, do I? Right? So now what do I got to do? I got to go find the numbers that I got to put in here. Otherwise, there's no math. So I go to my conversion factor and I look for what is the conversion between the word quarters and dollars, and I know that there are 4 quarters for every $1. So the expression, the number follows the unit. So I'm just going to look for the number with the word quarters, and that number is a 4. And what is the number that goes with the word dollar? That's number 1, right? So now it's just a math problem, right? Now I've got all the numbers, right? So I'm going to do the math, and I'm going to say that this is 508. That's a 5, 8 quarters. I'm just going to abbreviate the Q over 1. Now, why did I not have quarter dollars, or there's no dollars in there? Because the dollars get canceled. And 508 quarters over 1 is the same thing as 508 quarters. Now, does that make sense? Sure. 400 quarters would be $100, right? 500 quarters would be $125. So it does make sense because we have a little bit more than 125 quarters, right? So let's go to the next one, right? The next one is just as easy, and we're going to do the same thing. How fast is 125 kilometers per hour in miles per hour? So what am I given? This is what I'm given. So that goes right here. So let's just put that down here. And then that's km per h. and that goes over 1. Now, before we move on, I'm going to put km per h here. And now I go back to my problem, and I'm going to say, okay, what am I trying to find? How fast is blah in blah? So here's my in miles per hour. So I'm going to write miles and then per hour. All right. Now again, I don't have any numbers yet, so I have to go to my conversion factor, which is this, and I'm going to write the number that goes with each one. So where's the kilometers? That's 1.6. So that goes here. And what goes with the word miles per hour? And that's 1. So at the end of the day, it's 127 divided by 1.6, which equals 73.4, miles per hour. Again, what have I done? I've just basically did everything the same, right? So again, why is it not miles per hour, kilometers per hour? Because these get canceled. And so there's your sequence, all right? So we've tried it with some things that you're familiar with. Now we're going to try it with some units that are specific to chemistry. So there's only 2 conversion factors that you're going to have to worry about. 1 mole equals the molar mass in grams. 1 mole equals 6.02 times 10 to the 23rd particles of that thing. The word particles can represent atoms, molecules, formula units, etc., right? Now, depending on which way you're going in the conversion, are you going from moles to grams or grams to moles, will dictate how this conversion factor is written in the dimensional analysis problem. The same thing with the particle one, right? So they're all equal as far as size, right? That's why I have put a 1 here. The magnitude of this in size is equal to the magnitude of this in size. So it doesn't matter which way you write it, right? And that's like 1 dozen equals 12. 12 equals 1 dozen. So when you write these out, you're going to have to choose the correct orientation of your conversion factor. And I'll show you that on the next slide. Okay, so I've done a lot of the legwork for you before, but you have to do these practice problems. Remember, you're going to need the molar mass of your materials to do your moles to grams conversion. The molar mass is the conversion unit, right? So again, let's just quickly do this. I'm going to set up my equation. So circle the given amount with units, and this is my given amount. So that number, by definition, goes here with its unit. And then I put it over 1. Underline the desired unit. So this, what do we want to know? We want to know how many moles, right? So that word, mole, will go here, right? And then we have to set up your conversion equation. So remember, this part right here, this is my conversion factor. 1 mole of silicon, I looked this up, is 28 grams of silicon. So this is where I get my periodic table. So this number here would be from your periodic table, or you'd have to calculate it from the stuff from the periodic table. Okay? And then when you do that, you get the correct answer. Right? Okay, so again, in the last one we went from grams to moles. Now we're going to go from moles to grams. Again, you need to look up the molar mass of your material that you are trying to determine the moles to grams thing. So the periodic table is where you get this information. So again, we're going to circle what we're given. So we're given this. We're given 1.85 moles, and so that goes right there. So this is my given. And then what do we want? It's how many grams, right? So that's how many we want. This is what we want. Okay? And so the grams part of what we want, the grams, that is that unit there, and the moles is that unit there, and therefore we need to know what is the molar mass of silver. And so you look that up from the periodic table. That's from the periodic table. All right. Then you just plug it in and do the number crunching. When you do mole to particle conversions, everything is exactly the same, except instead of using 1 mole equals the molar mass, we're going to use 1 mole as this many particles. All right. So, but the process, the setup, everything else is the same. Okay, so now we're going to try moles to particles. So here we go. Let's quickly circle what we know. We know this. So again, that goes there, and that's my given. And what are we trying to find? We're trying to find the particles. So how many particles? All right, and so the word particle goes here. Right, so this is my want. Right, and then what are we trying to get rid of? We're trying to get rid of moles. So the whatever unit right here goes here. So these must match. All right, and now it's just this just becomes the conversion factor right here. That's your conversion factor. Right, so you got to again. The expression is the number follows the unit, and so you put in the correct unit for the number. Okay, so here's the last example of moles from particles. So we want to know how many moles are in this many particles. So again, I circle what I know. That goes there. That goes there. That's a given. Right, and what do I want? Moles, so that goes there. This is my want unit. All right, particles, if there's a word particles here, has to be the word particles here. And then the rest of it is just fill in the blanks where your units go. Excuse me, the numbers go with the units. Remember, 1 mole always equals 6.02 times 10 to the 23rd particles. So when you see the word particles, atoms, molecules, whatever, you're going to always think 6.02 times 10 to the 23rd when you're doing these types of conversions.